Hi everyone. For this session, I will continue Chapter 7, Quantum Physics. Okay, let's look at Paper 1, Number 1. Table 1 below shows part of electromagnetic wave spectrum. Okay, we have microwave, infrared, ultraviolet rays, X-rays, and gamma rays. Position of the visible light. Where is visible light? It's between infrared and ultraviolet. As we know that the spectrum is continuous spectrum. So the range is between infrared and ultraviolet. And here we have another one is radio wave here. Okay. X, U, V, I, and R. Okay. Number 2, which of following is a particle of electromagnetic radiation without mass? It's a photon. Photon can act as a particle or wave. So, but there's no mass. It's photon. Okay, number 3, which of following is known as classical theory? Classical physics. Number 4, diagram 1 shows photocell illuminated as light with wavelength lambda and intensity of light I. What is the change produced if light intensity increase? Okay, remember the photon energy, E equals to HF. Okay. Increase the intensity means the photoelectric current will increase. Wavelength, no. Number of photoelectrons emitted increase. Kinetic energy, no. Because kinetic energy all depends on frequency. The wavelength also same, depends on frequency, not intensity. So the number of photoelectrons emitted depends on intensity. Okay, the higher the intensity, the more the number of photoelectrons emitted. So when more photoelectrons emitted means more charge will flow or will move in the circuit, so it will produce larger current. So that's why 1 and 3 is correct. Answer is C. Okay, number 5. A beam of monochromatic light is incident on metal A, causes production of photoelectrons. The rate of photoelectron produced will be double if, just now we discussed that, number of photoelectrons emitted depends on intensity. Okay, intensity of light. So intensity of light double, so we can have rate of photoelectrons will be double. Number 6, black body is a superior body. It can emit thermal radiation depending on temperature. Okay, the color also depends on the temperature. Okay, the spectrum of colors emitted by the black body also depends on temperature. Number 7, determine energy released by quantum of radio wave frequency 103.3 megahertz. Okay, from the station. E equals to HF. Okay, the Planck constant 6.64, 10 to the power of negative 11. Sorry. 6.63 10 to the power negative 24 times 103.3 mega 10 power 6. Okay, so we get the answer for this one. 6.84 10 to the power of negative 26. Two. Sorry, I think that one is the Planck constant. 34. Nampak salah. 34 here, sorry. Okay. Wait. The Planck constant, you refer to the least negative 34. So your answer will be 6.84 times 10 power negative 26 joule. Check the list of formula. Okay, which of following is evidence of existence of discrete energy? Okay, the line spectrum will show a discrete energy, means each of the color has its own distinctive frequency and wavelength. So that's that one, discrete energy. Discrete energy. Okay, number 9, graph of K kinetic energy against frequency. So you must understand this graph. The intersect here at the F axis, this one is threshold frequency, and then the intersect at K max is work function, WO. Okay, so we can get two physical quantities, which is very important from this graph. Okay, which one correct represent the graph? And then the gradient of the graph, gradient, if you calculate the gradient, okay, is equals to, okay, let's see here is certain frequency. So is K maximum divided by F minus FO. Okay, so we get gradient is like this. This is K maximum, F minus FO. Okay, go back to the Einstein photoelectric theory equation, Einstein photoelectric equation. So we have this formula. E equals to HF. Ini yang kita dah baca awal. And then half ataupun K maximum equals to E minus work function. Okay, means HF minus HFO. So HF minus FO. Okay, so from here we get H equals to K maximum divided by F minus FO. So we look again, this one, compare with this one from the equation and the gradient. So we get the gradient actually equals to Planck constant. You can see there are three important points that you can get from the same graph. Gradient equals to Planck constant. Intersect at x-axis is threshold frequency. Intersect at y-axis is work function. Okay. So the gradient will be Planck constant. X-intercept, okay, x-intercept will be threshold frequency. The rest all wrong. And then the y-x-intercept is work function. So from here we get D is the answer. Okay. To understand this graph. Number 10. A red laser pen emits light wavelength 770 nanometer if number of photons emitted 4.47 times 10 power 8 per second. Means N is 4.47 10 power 18. So what is power output of the laser pen? The formula for power is NHF. Okay, but frequency is not given, so we use frequency equals to C divided by lambda from the formula of V equals to F lambda. In this case, V equals to speed of light, so C. So we get F equals to C divided by lambda, so NH C divided by lambda. So we just ganti saja 4.47 10 power 18 Planck constant C 3 times 10 power 8 divided by lambda. Lambda here is nano, so you need to convert to meter. Nano is 10 to the power negative 6 meter. Okay, solve for this one. You will get the answer in watt. Okay, so you will get the answer as C. 1.15 watt. Okay. Okay, let's look at the paper 2, section A. Diagram 1 shows laser pointer, usually used together with presenter. A wavelength of laser light given. The power of laser pointer 1 milliwatt. State one characteristic of photon. Okay, first you can say something like travel at speed of light, C. Okay, no charge or throw. Okay, what next is has energy and momentum, means can act as a particle. Okay, with particle duality. Okay, B is it possible to notice the individual photon in laser with unaided eyes? Explain your answer. We cannot see. We cannot see photon as individual like discrete. One packet, we cannot see like that. Now, what we observe is just like a continuous photon or light ray travel. Okay, no. Okay, the effect, the photon just can be observe as an effect of waves. Okay. Calculate energy of single photon in laser light. We have hc divided by lambda. If f not given, you can check whether its wavelength is given or not. So from here we can see all given. Atas ni ya. Wavelength is given. Okay, not frequency, and power 1 milliwatt. So just substitute, gantikan 6.63 10 power negative 34, 3 times 10 power 8, wavelength 6.7 10 to the power negative 2. Okay, so we get 2.97 10 power negative 19 joule. This is energy of a single photon of laser light. Number 2, diagram 2 shows semiconductor material in construction of photocell that can be activated. Okay, wavelength 1110 nanometer. What is meant by threshold frequency? Okay, threshold frequency is the minimum frequency of photons required for photoelectric effect to occur. Okay, name the theory that explains all characteristics of photoelectric effect. Very popular person, Einstein. Photoelectric theory. Okay. Complete the following sentences by marking tick. The higher frequency of light applied to metal surface, the more. Benda tadi sini. Higher the kinetic energy. So K maximum depends on the frequency of light photon. Okay. If frequency of light equals to frequency of threshold frequency of metal, K maximum equals to 0. Tak ada K maximum. But if frequency is more than the threshold frequency, K maximum increase. Okay. K maximum depends on the frequency of photon. So when frequency increase, K maximum increase. At the threshold frequency, photoelectron emits from the surface has no kinetic energy. State one reason why kinetic energy of photoelectron is 0. Okay, at threshold frequency means frequency of photon just equals to threshold frequency, and the work function required equals to HFO. Okay, so means there's no extra energy. Okay, so if W equals to HFO at the same time, E also equals to HFO. From the Einstein formula, photoelectric theory formula, we have this one. K maximum equals to energy of photon minus work function. Okay, so in this case, if energy of photon, which is HF. So we get this formula HF minus FO. Means if F equals to FO, this one will become 0. Thus K maximum equals to 0. Okay, so in this case, we can say that all energy of photons is used to overcome threshold frequency. Sorry, to overcome the work function or to supply work function for photoelectric effect to occur. Okay, the kinetic energy of photoelectron is 0 because energy of photon is entirely used to use as work function. Work function to release electron from the metal surface. Okay, means kinetic energy is 0. Energy of photon equals to work function. Okay, and then the value of threshold frequency of semiconductor FO as we discussed before, dia sama F equals to FO. So you akan dapat kinetic energy equals to work function. So threshold frequency we can calculate by using the formula FO equals to C divided by lambda O. Lambda O is threshold wavelength. Okay, we look at again what is given above here. Okay, photocell that can be activated with light wavelength, meaning here is the threshold wavelength. Okay, lambda O. Okay, and lambda O and threshold frequency is inversely proportional. You can get here from this formula C divided by lambda O. Okay. Okay, so you have 3 times 10 power 8 divided by 1110 times 10 to the power of negative 9 meter, because it is nanometer. Thus we get 2.7 10 to the power 14 hertz. Okay, so this is threshold frequency. Then part 2, value or working function or work function. Okay, work function of a semiconductor material W. Formula W equals to HFO. Means 6.63 10 to the power of negative 4 times work function just now. So we have 2.7 10 power 14. Okay, and then we get the work function 1.79 10 power negative 19 joule. Okay, so one is the work function of semiconductor W. Okay, but D give one reason why semiconductor material appears opaque at room temperature. Okay, we put the semiconductor instead of metal, so it does not produce photoelectric effect. Okay, at room temperature, thermal energy is not enough to release electrons in the photocell. Okay, number 3, variation of maximum kinetic energy Kmax of photoelectron frequency F of liquid in a photoelectric effect experiment. So Kmax against frequency again. So as I discussed before, the gradient of the graph equals to H, Planck constant. This is threshold frequency, and this is work function. Okay. Based on the graph, what is threshold frequency of metal? So here 5 times 10 power 4. Power 14, right? It's not 4. Check again the graph. Okay, it's 14, sorry. Will not be too small here. What is work function? Okay. Tengok graph balik sini. Negative 1.5 times 10 power negative 19. So no need to put the negative sign. 1.5 times 10 power negative 19. Okay, and then calculate the gradient. Okay, so we get the answer for this one, 6 times 10 power negative 34 joule second ataupun joule per hertz. Okay. What is quantity physics represented by gradient? That one is Planck constant. Bahagian B. When a metal surface is illuminated by a beam of light at certain frequency, electrons can be emitted from metal as shown in 6.1. This phenomenon is known as photoelectric effect. What is meant by work function? Okay, minimum energy required